I would like to start this session, and I would like to welcome our first speaker for this session, which is Dr. Costas Balaras, which is a research director in the Institute of Environmental Research and Sustainable Development of the National Observatory of Athens. He's a mechanical engineer and has over 30 years of experience in research, development and demonstration in the areas of energy conservation, sustainability, assessment of the built environment and energy audit. He's an ASHRAE Fellow and currently serves on ASHRAE Technologies Council as a voting member on SPC 2.40, evaluating greenhouse gases and carbon emissions in building design, construction and operation, and as a nominating voting member of SPC 189.1, design of high performance green buildings. And also, what this CV doesn't say is also that Costas was the man that introduced me to ASHRAE along other members as well.
Well, and I did well. So, good morning. Thank you very much for the introduction. It's always a pleasure. And kind of like a responsibility kicking off in our session. And by the way, you see, resilience is the first session of the conference. So, yes, indeed, there is great importance on this topic. And as things evolve, it will become even more important. Now, God, you wish I was here, right? But this is... There you go. I can handle that. Thank you. So, as we start, let me just remind everyone that we try a lot of times to just introduce and bring new information that we derive from research. I am in a national research lab. So it's always a great opportunity when we're trying to communicate these results from a project that we just started. It's called REMED. It is a collaborative effort, as you see here, between 9 partners from 5 EU countries. So that kind of like brings and illustrates the interest on this. We are at the beginning of our work, so I think we're just going to position where we are and hopefully tease you enough so that you will follow up. And the fact that you're here, you're interested because, yes, indeed, we do have a problem. And hopefully, most of the scientific evidence actually point where the problem originates from. It's from our activities. So we're trying to address, and I try to put on this the perspective of the complexity, because from the beginning we need to realize that this is not a simple black and white problem that we need to solve. And due to that complexity, the challenges increase. At least, though, for over a few decades, we know that buildings and the built environment contribute to that problem. So for us engineers, it's good to really know what the problem is and where it's coming from so that we can provide solutions. In terms of energy, about 40%. In terms of emissions, about 20+%. And if you add to that what we call the construction industry, the embodied energy, the embodied emissions, so we look at the whole picture, that comes to about 1/3. Also, the emissions are related to the built environment. All right, so we know who to blame, and we know where we're going. Hey, the future, if we want to succeed in being in this environment and being able to address the issues and the challenges, we need to really shape up and reduce energy. That's the first step, priority 1. So indeed, mitigation is really what we're aiming for, and very correctly. And in, well, not exactly tomorrow, but in a couple of decades, we need to be right there so that we have about a neutral, not zero in terms of energy and emissions, but about a neutral so that we can balance where we are. All right, so I get my magic rod, and I tell you, shoo, we're right there today. Would we solve the problem? No, unfortunately not. Because actually, who to blame? We said the built environment, are actually suffering from the implications and the impacts. So it's payback time. So we need, no matter how fast, and hopefully it will be fast enough, how much, and hopefully it will be significant, we'll be able to do in the next few decades, because the implications are already here. So we need, in parallel with what I said, step one, the most important, education, energy conservation, reducing emissions, whatever you want to call it, we need to adopt. Because we're going to be suffering from the implications in terms of express-event disasters, because of the hazards, because of the exposure, because of the vulnerability. And we need to be prepared. All right, so we're going to have, and we're already, depending, no matter, really, we have people from EU, from the US, from Africa. We're all, one way or another, suffering from these extreme, from these intense, and from these also frequent events, from high temperatures to low temperatures. Somebody was asking me yesterday, does it snow in Athens? Oh yes, look at the pictures on the left-hand side of the slide. This is Athens. We're getting over the past few years intense snowstorms that you can go skiing downtown Athens. Unbelievable? Yes. Well, the extremes though, on the higher, on the lower, are here. On the flooding, on the rainfall, and at the same time, look at the things that are just not making too much sense, and at the same time, the drought, the water scarcity, and then when it rains, we don't know how to handle and address the amount of water, and then, because of the high temperatures, the fire, the extreme events, we need to be prepared. Now, in terms of all these different issues, we start with, first of all, the urban resilience, meaning that we need to actually be able to operate, to handle the situation, regardless of all these different extreme events. Regardless of what's happening, we need to be able, in our cities, to operate. So we need to anticipate, we need to be prepared, and we need to be responsive so that we can operate with the minimum operations and functions. And when things go wrong, and they will, we need to be able to recover. Now, in all this, it's going to be easy to do? Well, it's going to be a complex approach. So that now increases the degrees of freedom, of things, of the parameters we need to take into account, and we need to be able to do all this in a very coherent approach. Now, where do we start? Well, the small scale, building. The building scale is the first step. So we need, in order to be able to have our cities resilient and service, we need to start from our buildings. That would also need to withstand the impacts. We need to be able to maintain the functionality. So we need to be able to withstand this extreme high, low temperatures, water, rainfall, snow, and this unexpected events that we don't even have power. So what do you do with all this? Well, one of the positive steps, directions we have already been taking with is the high performance buildings. Why? Because as we saw this morning with the ASHRAE headquarters, when you reduce your demand, your requirement, well, it makes it easier to handle. It makes it easier to resolve. So you have low energy requirements, then you can find easier solutions to that problem. You have, for example, what's one of the requirements of a high performance building? First, you minimize your loss, and then you have a renewable. So it will be easier with renewables, with PVs, for example, to provide power for your building operations. You need less storage, batteries, so that would make it easier. So it all makes sense, and it fits together. That's the beauty of it. Have we taken some steps? Yes, we are. For example, ASHRAE standard 189.1 already kind of touches on this issue. So it has requirements that it tells you, well, you need to control the ventilation system. If there is, for example, a forest fire, that there is smoke, to be able to shut it down. Yeah, it makes perfect sense that you protect your indoor environment. So already, these simple steps are already integrated in our building codes, in our standards. All right, so how do we move forward in this work? We need to first realize we're not starting from scratch. We have already developed, it's available, as a result of similar efforts, a tool, a method to assess sustainability of your buildings, of your cities, to quantify and be able to handle the complexity of what is implied with sustainability. Different tools with national variations. So this know-how that exists, we're trying to exploit and use, and already, as you see, some, and I mentioned some of the indicators that we use to quantify sustainability can also be used, gave some examples before, in terms of assessing resilience. Usually, behind these methods and the tools that we want to use, there's a lot of dirty work. There's a lot of background issues that we need to resolve. For example, how do you put together on your plate different indicators with different units? How do you compare the good or bad? For example, when we want to consider different indicators, we want to normalize the different scores. So if we have, for example, very high energy use, that's a bad score. So that scores below when we have a high indicator like the EUI, then we score low on the normalized score. If we have a low EUI, a low score of the indicator, that's better performance. On the other hand, if we have a lot of renewables, that means we can supply the power from PVs, that's a better score. If we have a low percent, that's a low score. That's the existing know-how that we have. You're able to use and compare apples and oranges. But you need to put them on the same scale. Also, the dirty work that's behind the scenes that you usually do that in order to be able to adapt it to your national priorities and everything is to be able to use weighting in terms of prioritizing different areas. The same thing we're doing when we assess sustainability, we can do here. So for specific hazards, we can put different weights that we can adapt so that we get the final score. Now, all that, it's in the background because the user usually wants something simple in order to be able, in these methodologies, to be able to handle the different issues. So, give you an example. If we have a hazard, extreme hot temperatures, then we need to take into account the vulnerability of our building. For example, if it has enough sufficient green areas. We also need to take into account the exposure, usually us, the human beings, the people in the area. The combination of all this makes the risk high. If there are no people living there, there's no risk. So there are no implications. So this is kind of the approach we're trying to take. The other research we have used is to look what's available out there already with similar methods, similar indicators, similar tools. And what we found out that we have, you see this high number of about 100 indicators that can be used to quantify these different issues, these different hazards, these different vulnerabilities that we have. What we have learned is what we actually expected, that the most frequent hazards used in the existing methodologies include the heat waves, include the floods, include the drought. Well, what else do we have? Each EU member state, each country is also, over the years, has been put on the right track in order to start assessing and put in national plans, along with the solutions in terms of sustainability, of what are the important hazards in the different countries. So all that knowledge, again, exists. So we're trying to collect that and actually process it, so we see what surfaces, and again, the changing temperature, the heat waves, precipitation, and drought, again, the same countries, because of the experience that they have, they're being timed, we need to be prepared in order to handle this. And then the next phase these plans address is, how do you see things evolving in the next year? So there is, again, a lot of information that is being included in these plans. We're trying to extract that information, and again, what we're hearing and know is things will get worse. Everybody is kind of appreciating, everybody, all the different countries are including in their plans and realize, this is not going to get any easier. So again, you see, we have now collected the existing knowledge, the existing importance, and where we want to take it in the next about 2 years of work that we have initiated. Well, we are right now, as we speak, in this, as we said, 5 different EU countries. We're trying to collect these indicators, the existing know-how. We're going to be putting in the existing infrastructure that I tell you that we have for sustainability. This will be the same concept, something simple, something open for all to use, because we're aiming to provide this capacity to municipalities that are mainly responsible in order to handle the resilience of our different cities, of our different areas. And we're going to be testing, we're going to be actually validating. We have 4 municipalities, 4 cities that participate in the project that will be using as a testing ground for our case studies that will validate and will return know-how feedback. Because if you have indicators that you cannot quantify because you do not have the information, hey, you need to start doing something like that. But the first step is to realize what you need. You have to do your housekeeping. You have to realize if you have the data, if you have the information, and then use it. At the same time, we will prepare training material, so that would again be available so that you can use, that you can train yourself if you're interested in that area, that you can provide services. The cities can train their technical departments, and altogether, this will be brought in a comprehensive decision support framework, because the first step is to assess the risk. How bad is in your area? How bad is your building prepared in order to be able to handle all these complex issues, problems? And once you do the diagnosis, what's next? Being able to evaluate what needs to be done and how effective would that be? Either as a plan, so that you can compare different scenarios, or as monitoring in terms of the success, the implementation of the work. I think I see people screaming, I want more, I want to learn more, this is interesting. Well, stay tuned. That's what we're trying through these presentations, to give you the coordinates. So in the presentation, you will be able to find the website. This is ongoing work, it's developing. If you're interested, follow up, because more and more will be coming available. It will be open and available to everyone interested to take and use. And the fact that we have different countries involved, it will be in English, and then it will be, and since we also participate here, in Greek. So sometimes the language can make a difference, but it's more than just the language, it's more than just translation, because it's adaptation of the material into the reality that we have in the different countries, in terms of the benchmarking, in terms of really adapting the information, the parameters to the needs of the local environment. So stay tuned, more will become. We'll get you started with some good bibliography, and especially if you were interested, if it teaches you that something is already available for sustainability. Yes, it is. So it is, again, as I said, open and available, and in different also languages and so forth. This is powerful approaches, information, and hopefully we'll be able to manage it in best way so that we can also address this important issue of handling the situation that we have created. Resilience will actually get us through these problems. Thank you very much for your attention.
I think we should add a question in the slide about timing, and I will give you 100, not 20, 100. Thank you very much about that, Costas.
Thank you.
Are there any questions, please?
Great.
Thank you very much. That was very interesting and very inspiring as well. A very quick question with regards to the latest news coming from the recent COP and the ongoing concerns about maybe it's now too late to achieve the 1.5 degrees Celsius of climate change targets. Do you think this is a problem? Is this being addressed by the methodology being developed?
Well, no, it's not being addressed because we're still expecting the input. What we're trying to do is assess your infrastructure, assess what you're having in order to be able to address the different phenomena, whether that is at extreme temperature, snowfall, whatever. So what needs to be done there is your benchmarking. What is important is to define your benchmarking. What is your current minimum requirement, and then where you're aiming. An example, to handle floods. So the city, for example, where I live was... Okay, I got the message. I need to stop. The flooding was every year. We're flooding. My house was flooded because there was no way to handle the water, the capacity of the rainfall. So finally, as we speak, they're digging all over the place and they're installing the infrastructure that you need to handle the increased rainfall. So that's what this methodology will actually tell you. What is the minimum requirement that you be able to handle how much rainfall? Okay, how much do you get now? Is that increased? That will have to also be complemented with a better assessment according to the new scientific evidence of where we are, where we're going. But we're not, your question was saying, well, what does that mean? That has, as you said, very important complications that will make things even harder. If anything, I think the message that's been coming that we're not moving fast enough and we need to actually address that, which is the first step.
Before asking if there's any other question, I'll let you know that the first question in Slido is open, so you can please go on with the evaluation. And remember that there are two questions. One has to do with the topic, and another one has to do with the presenter. Any other questions, please?
Great, thank you.
Thank you very much, and thank you very much for the time.